For this video, we're going to be looking at writing and graphing geometric sequences. So given the geometric sequence, write a function and use it to create a table and a graph. So I have this sequence 32, 16, 8, 4, and 2. And I know it's geometric, so it tells us it is. So I'm going to go ahead and find my first term, and then I'm going to find my ratio. So my first term I see is 32. And then my ratio, I can take the second term, 16, and divide it by the first term. And then when I simplify that fraction, I get 1/2. And so that means that my explicit formula is going to be AN, which is A1R to the n minus 1. And so plugging in everything I know, my first term is 32, my ratio is 1/2, and I get to the n minus 1. Okay, now we're going to use a sequence to complete the table and then graph. And then we're going to think about what we notice. So I'm going to have n be 1, 2, 3, 4, 5. And remember, this is just my term number. And this will be that nth term. So the 1 stands for being my first term, and so I want to find what my first term actually is, and I can look at my sequence above, and so I see that my first term here is 32. My second term is 16. My third term is 8. My fourth term is 4. And then my fifth term is 2. And now I'm going to go ahead and graph that. So my first term is 32, so it's going to be somewhere up here. My second term is 16. My third term is 8. My fourth term is 4. And then my fifth term is 2. And if I were to keep going, my sixth term would be 1, and so on. And so what we notice is with our geometric sequences, we get an exponential function. And we see that our explicit formula is in that format that exponential functions were, which remember was y equals a b to the x. So arithmetic sequences, those are linear functions. When you graph them, you get a line. With geometric sequences, those are exponential functions. So when we graph it, we get an exponential. Okay, let's go ahead and do one more. So here, my first term is 1. My ratio is going to be my second term divided by my first, which is just 3. So that means that my explicit formula is AN is equal to A1, which is 1, times R to the n minus 1. But you can also simplify that to be 3 to the n minus 1. So now I need to fill out my table. N is just my number of terms, so my first term is 1. My second term is 3. My third term is 9. My fourth term is 27. And then to find my fifth term, I just need to multiply that by 3, because that's my common ratio. And so when I do 27 times 3, I get 81. And then I can go ahead and graph it. So I'm at 1, 1, 2, 3, 3, 9, 4, 27, and then 5 will go off the graph. So I'm going to go ahead and just stick with those 4, and I get that for my graph.